6-2 kites and trapezoids. All right, example 1, how are the diagonals of a kite related? Okay, so first thing we want to do is we want to create the diagonals. Okay, so I want to create my diagonals. Try that again. Zoom in. Okay, I've got one diagonal. I want to create my other diagonal. Okay, so I have my two diagonals. I know that with a kite, this side is congruent to this side, and then this side will be congruent to this side. Okay, I know that my diagonals are creating perpendicular bisectors, so each of these measures on the inside would be 90 degrees. All right, I'll try it. What is the measure of AXB? So AXB is going to be 90 degrees because we have those perpendicular bisectors being created. All right, next they tell us that if AX is 3.8, what is AC, so the entire length? Okay, so we're going to take 3.8 plus 3.8 to get 7.6. Kite diagonals theorem. So the kite diagonal theorem, try to even this out. The kite diagonals theorem tells us that the diagonals inside of a kite create perpendicular bisectors, so it's creating 90 degrees on the interior. All right, next we're gonna look at example 2. So example 2, quadrilateral PQRS is a kite with diagonals QS and PR. What is the measure of angle 1? So we know that those diagonals are creating perpendicular bisectors, so the measure of angle 1 would be 90 degrees. Then they want us to find the measure of angle 2. Well, I know this would also be 90 degrees. The angles inside of the triangle would be 180. I'm going to subtract off the 35 that I know, along with the 90 that I know. That's going to leave me with 55 degrees for the measure of angle 2. Measure of angle 3 is congruent to this 35. So measure of angle 3 would be 35 degrees. All right, I'll try it. What is the measure of angle 1? Again, we're creating perpendicular bisectors in here. So I would take 180, subtract off 90, and then 32, which is going to leave me with 58 degrees. All right, now they want us to find the measure of angle 2. Well, angle 2 is congruent to that 32 degrees, so angle 2 would be 32 degrees. All right, example 3. Right. Kaio is designing a trapezoid-shaped roof. In order for the roof to be symmetric, the overlapping triangles DAB and ADC must be congruent. Will the roof be symmetric? So they already gave us two congruencies, so I know this is congruent to this one. All right, I know that BC is parallel to AD, and if BC is parallel to AD, I can create a bisector that will create a 90-degree angle. I'll call this E and I'll call this F. And this side would be congruent to this side. Okay, so we know that triangle ABE would be congruent to triangle DCF, and that is through hypotenuse leg. Okay, next we want to try to prove that triangle DAB is congruent to triangle ADC. We know that angle DAB is congruent to angle ADC, and that is their congruent parts of congruent triangles are congruent. We know that AD, side AD, is congruent to DA because of the reflexive property. So that side is congruent to that side because of the reflexive property. So finally, we can prove that triangle DAB is congruent to triangle ADC because of side angle side. Okay, because the overlapping triangles are congruent, that means that the roof is symmetric. All right, or try it. All right, given the isosceles trapezoid PQRS, what are the measure of angle P, the measure of angle Q, and the measure of angle S? Okay, we know that the measure of angle Q would also be 135 degrees. Okay, I know because there are four sides, the interior angles would add up to 360 degrees. So I would take 360, subtract the 135 I know, the 135 I know. That would leave me with 90 degrees. That 90 degrees is for the measure of angle P and S. So I'm going to take that 90 degrees, divide it by 2, which would get me 45 degrees for the measure of angle P and the measure of angle S. So that means that the measure of angle Q is 135. The measure of angle P is 45, and the measure of angle S is also 45 degrees. All right, V, given that ST is parallel to RU, so this is parallel to this. What is the measure of angle TUR? So I want to find this angle. Okay, I know that that angle would be congruent to this angle. They tell me the exterior of that angle is 47, so I'm going to take 180, subtract the 47 from that to get 133 degrees. So the measure of angle TUR would be 133 degrees. Because this is also 47, which means this has to be 133, 33, and this has to be 133. All right, next we're going to look at the isosceles trapezoid base angle theorem. Okay, so in an isosceles trapezoid, each pair of base angles is congruent. So that means that my base angles have to be congruent. So this angle would be congruent to that angle. And then this angle would be congruent to this angle. All right, isosceles trapezoid diagonals theorem. So this theorem tells us that the diagonals of an isosceles trapezoid are congruent. So my diagonals are congruent to each other. Okay, example 4. All horizontal beams of the high voltage transmission tower are parallel to the ground. The center station is an isosceles trapezoid. They tell us that the measure of angle 1 is 138. And we want to find the measure of angle 2. They told us that this is parallel to this, as well to this. Okay, so if angle 1 is 138 degrees, that means this would also be 138 degrees. We are looking at the isosceles trapezoid at the very top, so there are 4 sides. So that means there's 136 total degrees inside for our interior angles. We already know 2 of those. But we are missing the other 2, which would be congruent to each other, so we will name those X. I'll go ahead and simplify. I'll add the 138s together and then subtract them from 360 to get me 84. And then divide by 2. So the measure of angle 2 is going to end up equaling 42 degrees. All right, B. One cross support in the center of the tower measures 4C plus 3. The other measures 6C minus 5. What is the length of each cross support? Okay, so they're telling us that the diagonals, they're telling us those measures. I know my diagonals are congruent to each other, so I can set these equal. So 4C plus 3 equals 6C minus 5. I'm going to solve for C. Divide by 2. So C is going to be 4. But I don't want to know what C is. I want to find the length of each of the cross supports. So now I'm going to plug that in. So 4 times C, which is 4, plus 3. So I would get 19 for one of my diagonals. My other diagonal is congruent, so it should also be 19. I'm going to go ahead and plug it in to double check. So 6 times C, which is 4, minus 5. I would also get 19. Okay, or try it. Give an isosceles trapezoid MNOP where the given expressions represent the measures of the diagonals. What is the value of A? So I know these 2 diagonals are congruent to each other, so I'm going to set these equal. All right, so we get 14 for the value of A. All right, next we're going to look at trapezoid mid-segment theorem. So in a trapezoid, the mid-segment is parallel to the bases, and the length of the mid-segment is half the sum of the lengths of the base. Okay, so our mid-segment is parallel to the bases. Okay, so that means that this would be parallel to the base on top and the base on the bottom. The length of the mid-segment. All right, and then the length of the mid-segment is half of the bases. So if I added my AD together with my BC, half of that amount is the value of XY. Okay, so let's look at an example. Paxton makes trapezoidal handbags for her friends. She stitches decorative trim along the top, middle, and bottom of both sides of the handbag. How much trim does she need for 3 handbags? Okay, so we've got our trapezoid. We need to find the measures of the mid segment. Okay, so we know our mid segment is half of the bases added together. So I'm going to take half of my bases added together, 6 plus 9. All right, so I'm going to add my 6 and my 9 together to get 15. So half of 15, I would get 7.5. But we don't want to know just that mid-segment measure. We want to know how much trim in total we need. So now I'm going to add my bases and that mid-segment together. So 6 plus 9 plus 7.5 get me 22.5. She's making 3 handbags, and each handbag has a front and a back. So we're going to take the 22.5, we're going to multiply by 2 because of that front and the back, and then we'll multiply by 3 because she's making 3 handbags. So in total, she's going to need 135 inches of trim. All right, our try it. Given trapezoid JKLM, what is KL? Okay, so on this one, we have one of our bases, but we don't have the other base. But they told us what the mid-segment is. So they're telling us our mid-segment is 25. And we would normally take half of our 2 bases added together. Well, we know one of our bases is 4/5 XY, which XY is 25, so I'll go ahead and plug that in. And then our other base is KL. Okay, I'll go ahead and distribute out that half. All right, the 4/5 times 25, I'd get 20, so half of 20, I'd get 10, and then half of KL. Subtract my 10 over. I will multiply by the reciprocal. So I'm going to get 30 for KL.